Welcome everyone to this tutorial session. In today's tutorial, we have the equation 8x to the power 6 plus 7x cubed is equal to 1 to solve for x. Remember, look at it. It is a polynomial equation of degree 6. So we are expected to have 6 solutions. So let's get straight into our solutions. 8x to the power 6 plus 7x cubed is equal to 1. The first thing to do is to take this one from the right hand side to the left hand side, so that we'll have 0 on the right hand side. We have 8x to the power 6 plus 7x cubed minus 1 is equal to 0. This is the polynomial equation of degree 6. Now, if you look at it carefully, we don't have to panic. The power 6 should not intimidate us, because power 3, power 6, there is a relation. We can just write this power 6 as power 3 multiplied to 2. So that we'll end up with a quadratic equation in terms of x cubed. Let's go ahead. So 8x cubed to the power 2. Alright? Remember, 3 times 2 is 6. Alright. Plus 7x cubed minus 1 equals 0. You see, we have chosen x cubed because here there is x cubed. Now, our external power is 2, which makes this a quadratic equation. Alright, let's make it clear. If we do the transformation, capital X to be x cubed, wherever I find x cubed, we'll put capital X. So this equation now becomes 8 capital X squared plus 7 capital X minus 1 equals 0. This is the quadratic equation. We have reduced that equation of degree 6 to an equation of degree 2. Now let's collect our coefficients carefully. A is the x squared coefficient, B is the x coefficient, and C is the constant term. Make sure we collect this information accurately. Then we'll put in the quadratic formula. Put in the quadratic formula, we're going to have capital X is equal to minus B plus minus the root of B squared minus 4AC all over 2A. So we're going to have minus 7 plus minus the root of 7 squared minus 4AC all over 2A. This gives us negative 7 plus minus the root of 7 squared is 49. Minus minus become plus. 4 times 8 is 32 all over 16. So we're going to have the first value as negative 7 plus 49 plus 32 is 81. So we're going to have root 81 all over 16, which is going to give us negative 7 plus 9 all over 16, which is actually 2 all over 16, which is 1 all over 8. Alright, x2 will be negative 7 minus the root of 81 all over 16. Again, root 81 is 9, so negative 7 minus 9 all over 16. This gives us negative 16 all over 16, which is negative 1. So we have our two values. X1 is 1 all over 8. X2 is negative 1. We have to work with these two solutions. Now, our solution does not end here. We will not have to solve for capital X. We have to solve for small x. Okay, so bringing in small x, we have to use our transformation again. Remember, capital X was small x cubed. Let's bring this one back there. So, when capital X is 1 all over 8, we can just write that as, we know 8 is 2 to the power 3. We can just write this as a half cube. We are choosing a half cube because our small x is cube. We want the powers to be uniform. That's why we do this transformation. Now let's put it there. So we are saying that small x cube is equal to a half cube. We should avoid the error to hastily conclude that since the powers are equal, therefore x is equal to a half. That will give us only one solution. We're supposed to have 3 solutions here. So let's bring this one from the right hand side to the left hand side. That will mean x cubed minus a half cube is equal to 0. Difference of cubes expression. So we use the difference of cubes identity. That will mean x minus a half into x squared plus x all over 2 when we take their product plus 1/4 when we square a half. When we square a half, we have 1/4 is equal to 0. Product of two expressions giving us 0. It means either the first one is 0. If this is true, it means x is equal to a half. That's our first solution. Or the second one, which is a quadratic, is equal to 0. This is going to give us the remaining two solutions for the first case, x1. All right, so we collect our coefficients. A is 1, B is a half, C is 1/4. Now let's put it in the quadratic formula. Let's put it in the quadratic formula. So we have small x is equal to minus b plus minus the root of b squared minus 4ac all over 2a. This is going to give us minus a half plus minus the root of a half squared minus 4 into 1 into 1/4. All of that divided by 2 into 1. This is going to give us negative half plus minus the root of a half squared is 1/4. This 4 here cancels with that 4, so we have 1/4 minus 1 all over 2. So we have negative half plus minus the root of a quarter minus 1 is negative 3/4 all over 2. Now, the root of negative 3/4 is simply the root of negative 3/4 is simply root of negative 3 divided by root of 4. Now, root of negative 3 is simply root 3i, and then root of 4 is 2. We should remember that. We have been working with this already. So let's take this and put it there. We are going to obtain the first solution for x1 and the second solution for x1. So we're going to have x equals negative half plus minus root 3i all over 2. All of this divided by 2. This is just going to give us, when we arrange everything, we have negative 1 plus minus root 3i all over 4. Okay, this gives us two solutions. We have x equals negative 1 plus root 3i all over 4. We have x equals negative 1 minus root 3i all over 4. Okay, these are the two solutions for x1. For x1. Now let's take x2 to get the other three solutions for our polynomial equation of degree 6. Now x2 says when x is equal to negative 1. Okay, when x is equal to negative 1, remember again, capital X is x cubed. So we are writing small x cube is equal to negative 1. Okay, we do not rush hastily to say let's take cube root of both sides. If we take cube root of both sides, we're going to end up having just one solution, x equals negative 1. So let's bring this from the right hand side to the left hand side to obtain x cubed plus 1 is equal to 0. This is x cubed. We can write 1 as 1 cube in order to have sum of cubes. So this can be written as x cubed plus 1 cube is equal to 0. We use this because we know the identity of sum of cubes. The identity of sum of cubes says that a cubed plus b cubed is the same as a plus b into a squared minus ab plus b squared. When we use this identity here, we're going to transform this left hand side to resemble this right hand side here. So we're going to have x plus 1 into x squared minus their product plus 1 squared is equal to 0. Product of two expressions giving us 0. Either the first expression is 0. If this one is true, it means x equals -1. That's the first solution of our x2. And then all this other one, this quadratic, is 0. It's going to give us the remaining two solutions for x2. So let's collect our coefficients. Our a is 1, our b is -1, and our c is 1. Now let's put that in the quadratic formula. In the quadratic formula, we're going to have x is equal to minus b plus minus the root of b squared minus 4ac all over 2a. Let's put in a, b, c, d carefully. It's -1 plus minus the root of -1 squared minus 4 into a, and then c. All of that divided by 2. So we have negative plus minus the root of -1 squared is 1 minus 4 all over 2. So we have 1 plus minus the root of -3 all over 2. Root -3 we all know is root 3i all over 2. So here we have the remaining two solutions of x, capital X2, which now gives us x equals 1 plus root 3i all over 2 and x equals 1 minus root 3i all over 2. So we've gotten all our 6 solutions for the polynomial equation of degree 6.